So again, let's look at this. So what, if you look at this, so let's take this bulb. So this is my the V. This has some resistance R, and there is a current that goes through I. Now, if you take this light bulb, so this is a light bulb, and let's see what is going on inside the light bulb. So we have this resistance here. This is my light bulb. Now, as I said before, this is called, it's called the filament, which is a wire that has a resistance of R. Now, what is going on is that as current is coming in, this is I. Now, do you see that this current is going to go through this wire here and then goes like that? So when the current goes through this wire, it generates an amount of heat that is called I squared times R. And this is called the Joule. So let me explain what this happens here. The temperature of the wire is going to increase. And this is what is going to cause that, it's going to cause it to so basically a light bulb, so basically what you're doing is that you're just passing current, and then the current is going to heat up. So when this current goes in, you're just heating up, so you're heating up the and because you're heating this up, the temperature is going to go up, right? And when the temperature goes up, it's going to change color, right? So for example, at low temperature, maybe it's just going to be something like black. And then when you heat this up to high temperature, it's going to become red. So this will cause the light bulb to show up as a red light. But again, I'm saying that the basic principle is it's a very simple principle here. It's just the current going through a resistor is generating a heat. And this heat is called the Joule. So this can be calculated very easily if you know the current and if you know the resistance. You can calculate how much amount of power is given to that light bulb at any point in time. All right, so this was just one application that I wanted to talk about. So let's go back to the, so let me go back to my PowerPoint. So you can think about like electrical, maybe like electrical power lines. So basically what this does is just to, so this is just to transport So each time that you think about electrical energy, always think about what is the voltage and what is the current. Now, in some applications that I'm not going to talk about here, but so later on, I guess if you guys are going to take a different course, maybe electrical science or something like that, we'll talk about something that is called the transformer. So what a transformer does is that you want to transmit the current at very high voltages, right? But then for domestic applications at home, you don't need very high voltage, so you need something to switch that voltage back to. So for example, maybe the voltage here could be as high as maybe like 1,000 or maybe 10,000 volts, right? But for domestic applications, you probably just need about 120 volts or something like that. So you need a transformer to step that down from a high voltage to low voltage. But again, when you think about electrical power transmission, there are two quantities that are important. One is the current and one is the voltage. And when you combine those two together, you can form the power, which is just the current times the voltage. Now, let's take a look at one example here. This is example number 24.6. And so I want to look at power in an electrical heater. Now, an electric heater is pretty much the same as a light bulb. So again, this is just a wire. So if you remember, an electric heater looks like it's just a coil. So it's a wire. And this is going to be connected to some power supply. Like that. And then this coil has a given resistance, R. So let me try to draw this in a way that looks much more. Let's think about it like this. So this is plus and this is minus, and then this is connected to the coil. That looks like that. And so if you know what the resistance of the coil is, so this is my delta V, and then it tells me that the coil is made up of nichrome wire that has a resistance of 8.0 ohms. So I want to find, so what is the current in the wire, and what is the power rating of the heater? So again, as I said, you can just look at any of those equations that we've seen. So in this case, you can calculate your current using this equation here. Then you know what the power is.